All right, welcome back to LouTube, and this is the part 2 of the culminating review for the applied math students in January of 2021. And so I'm going to finish the review, which is the last 3 pages of it, or my review portion of it, to help students go through their actual culminating activity. Note, this is not the assignment part that needs to be completed by you, but this is the review to help you so you can go through your work, okay? So we finished off on last video on the substitution, solving linear systems by substitution, and now we're going to go on to the quadratics, and it starts with question number 13, where they want you to distinguish between linear straight line functions, quadratic functions, or C for a circular function. So what you're looking for here is the number of variables that are squared, which means x squared, y squared. If you have no squares, okay, so I'll turn my pen on here, no squares, okay, then you are linear. If you have the x only squared, you are quadratic. And if you have x squared and y squared, then you are circular. So when I look at the very first one, I see I have y and I have an x squared, so therefore this is quadratic, so I'd circle the Q there, okay? Then I look at the next one down, x and y, y equals x plus 4, so y equals x plus 4, that is clearly linear, there's no variable squared, so we'd circle linear. And then when I look at the next one over here, I have an x squared and I have a y squared. That tells me it is a circular function. And then the next one is y equals x squared minus x, 4x plus 4. That is still only got an x squared. It does not have a y squared, so it is quadratic. So I'd circle the quadratic, okay? And that is as simple as those kind of equations go. Just being able to recognize the difference between a quadratic function and a circular function. Some of the other things that we'll notice here is a line will be straight, okay? It's going to be perfectly straight. A quadratic is going to be a parabola shape, and the circular functions are going to be circular, oval shape. They're going to come around back onto each other, okay? So that's the difference between each of those ones. This unit, we're focusing on quadratics, so parabolas are what we're going to be dealing with. All quadratics form a parabola of some sort, okay? All right, let's move on, and we're going to do this one here where I showed you how to do these questions here, and you want to be able to do the vertex and the step value, and that would be valuable information in graphing, which we'll do later. So to get the vertex, the x value of the vertex comes from this point here. You might have remembered y equals ax minus p squared plus q, and your vertex is your p-value, which changes sign. So this would be your x part of it is 2, and your y value of the vertex does not change, so that will be 7. And your standard step values are 1, 3, 5, ... and they are multiplied by the a value. In this case, 3 minus 3 is going to multiply by each of those. So the first term is going to be minus 3, the second would be minus 9, then it would be minus 15, and then minus 21. If you kept going, that would be 7 here, and you get your step values, okay? So we're simply multiplying those out. Now, graph the following quadratics by stating the vertex and the step value. So we can do this here quite easily. I've tried to keep these fairly compact so we don't have to use a lot of paper, and it seems to work quite well. Okay, so first thing I do is I get my vertex. So in this case, this is going to give me my x value of my vertex, change the sign, that's minus 1. This one's going to be my y value of the vertex, that's 4. So I can plot that point. So label my graph, that's always going to be worth a few considerations for a mark, okay? And then it's minus 1 and positive 4. So minus 1 on the x, positive 4 on the y. 1, 2, 3, 4, and there's my vertex, okay? I see that my a value is negative 1, so I know it's going to open down. So I will often label my vertex on top then, get it done right away so it's out of the way, and then I will go over here and do my step values. So this will be, if you want, you can write 1, 3, 5, 7, and then I'm going to start multiplying by negative 1/2 because that's my a value, okay? So it's negative 1/2. It's going to be multiplied. So negative 1/2 will be the first one. Then it'll be 3 times negative 1/2, which is actually negative 1.5, and then negative 2.5 and negative 3.5 as I go, okay? And I'm just multiplying 1/2 by each of these things. So half of 3 is 1.5, half of 5 is 2.5, half of 7 is 3.5. The next one would be 4.5, and so forth, okay? So that means that in order to graph it, I go across 1, and in this case, because they're negative, I'm going to go down 1/2, and I'm going to make a point right there. And I'm going to do that on both sides, okay? And then I'm going to go down over 1 again, and down 1.5. So over 1 and down, there's 1/2 and 1 more. So there's 1, and I can do the same thing on the other side, and you can start to see how my parabola is starting to take shape. Then I'm going to go down 2.5. So over 1 and down 2.5, right? Over 1 and down 2.5. And this was the method that I taught you in class. And then finally over 1 and down 3.5. So 1/2, 1, 2, 3. We'll leave it at that. That's probably more than sufficient. And then of course another point on this side. And so now you can start to see my shape, and the purpose is to draw it. Remember, they're not supposed to make V's. They're supposed to be smooth and round. So do your best to sort of come around and draw them. It's not easy for me either with this on the computer. And put arrows on the end of the parabola to indicate they continue on. And then finally, I can label it with my equation, which is y equals minus 1/2 x plus 1 squared plus 4. And that would be a completed graph, okay? There's an example for you of graphing in slope or intercept form, okay? Then we can come to one doing it by roots, okay? So I've adjusted the graph slightly. Hopefully this works for us here so that we can see it. Actually, I'm not sure that it will work for us because it should be going up and not down. So I'll make sure. I might have to adjust my graph here just slightly, so bear with me. What I'm going to do is, I think I changed this from one of the ones in your assignment. So I'm going to increase the number of, I'm going to insert a number of rows above, and then I'm going to delete some rows below. Okay, go like this. And you shouldn't have to do any of these things, so don't worry about it, but we'll go like that. And that just moves my x-axis a little down. If you don't like where your x-axis is, you can just redraw it in at a different place. Okay, so now my roots are where it will cross the y-axis, where this equation will be 0. So if you think about it, y becomes 0, and you have x minus 4x plus 2, and you can ask yourself, well, where along here is this going to be 0? And this will be 0 when either of these two things become 0. So x equals 4. If you put 4 in here, 4 minus 4 would be 0. Or if you put minus 2, because minus 2 plus 2 would be 0. So my roots are 4 and minus 2. And I can start by plotting those, because sometimes plotting that really helps it come to make some sense for students, okay? So I encourage you to do this, okay? So if you plot 4, 1, 2, 3, 4 on the x-axis and minus 2 on the y-axis, you start to see where this equation is going to go. We know that our parabola is going to cut through these things, okay? Well, maybe I didn't need to move the y-axis. That was silly of me. Maybe I should have left it where it was. My bad. Oh, it's always doing something stupid. Here, so what we're going to do is we're going to find the midpoint between 4 and -2, and that ends up being 1. Okay, so if I come in 3 from this side and I come in 3 from this side, that is 1. And I know my vertex is going to be right down this line of 1. So what I know is I know that 1 is the vertex here. And I often tell students just do it by inspection. So the x value of the vertex equals 1. And that can be calculated by doing if you want to do the math on it, it's basically 4 plus -2 divided by 2, and that equals 1, if you want to do it mathematically. But I think just doing it visually is easier, okay? You can just see that's where it is. Now, if I take that in, I want to find the YV, the Y value of the vertex. I'm going to put 1 in for x. 1 minus 4 times x plus 2, and that would be sorry, that should be a 1 there, and that would be -9. So this works out to -3 times 3, which equals -9, and that is the Y value of my vertex. So when I do the math there, I just put the 1 in there instead of the x. Okay. Now I'm gonna go back and do the exact opposite what I did before. I'm gonna take these and move my vertex or my y-intercept back down, so I'm going to delete these cells, delete entire row here, and then I'm going to add some cells below because that's what I should have done. I should not have messed with it, but I did. Insert rows below. That should give me enough room now to, does that give me 9? I hope so. Okay, now I'll see if my eraser, now of course my eraser doesn't want to work, so you're going to have to bear with me. Oh, actually that's okay. There we go. Hang on a second here. Okay, so I'm going to just put my arrow there, label my x, label my y. Now I want to go to 1, x is 1, and y is 9. 1, not -9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and there is my vertex. Okay, so that is 1 minus 9, and my step values, there is no a value out front, so my step values are simply 1, 3, 5, 7. Now you don't have to plot these step values, but you could. There's 1 there and 1 there, 1 over, 1 up, 1 over, 1, 2, 3 up, and 1 over, and it should be 5 up, and it works out perfectly that becomes this point on the roots. Okay, now I've got the roots in place. I can just simply go like this and try not to make it look like a V, and there's my parabola, and label it y equals x minus 4 times x plus 2, and I'm all done. Okay, so a little tougher, a little trickier, an extra step in there in figuring out where your vertex is, but it's not beyond your abilities. We definitely did some of those in class. Okay, and then the last one is one where you would have to actually take this equation and get the roots, step value, and vertex by factoring first. So what we want to do is we want to factor this. So remember, factors of 3 that have a difference of 2. And then that means I'm going to do this factoring here. So I go x and I go x. 2 numbers that multiply to 3 and have a difference of 2. And the bigger one will be positive. So that will be 3 and 1. And 1 will be positive, 1 will be negative. And this becomes my equation. And this starts to look a lot like this question up here. Okay. So now I can get my roots. My roots will be positive 1 and minus 3. Halfway between positive 1 and minus 3, we'll add them together. What's 1 plus minus 3? That's minus 2. Divide by 2 is minus 1. So the x value of the vertex is minus 1. Okay, and then I'm going to substitute that back into my equation here. So that will give me my y vertex. That will be -1 plus 3 times 1 minus 1 minus 2 minus 1 minus 1, sorry. This works out to 2 times -2, which equals -4. And so -4. And my step values, again, no a values, so it'll be 1, 3, 5, 7. And I did that as an example. You could now plot that very similar way we did this one or the one above, and you could graph it. And that is the quadratics, graphing quadratics component of the course right there. Okay, it's not easy. It's definitely probably the hardest part of the course, and it's usually where some of the students just give up. But if you just take your time and think yourself through it, you can probably get it. It is a little bit of work. All right, so now we're going to do similar triangles. Okay, so what I'm going to do is I'm going to identify my similar sides. So this one's pretty straightforward. I've just changed to a highlighter, so this side and this side are similar. I'm going to change my color now. I'll go to green. I'm going to go like this, the green and green. And if you want, you can do one more color. Since I have lots, I'll do this. I'll do blue. And I'll go blue here. Why is my... There we go. It disappears. And now I've made my connections to my similar corresponding sides. So I'll do the x on one side here and solve for the y on the other. Okay. So x, let's do 3 goes to 21. Okay, 3 is going to 21 because they are corresponding. And then if I want to do for x, I have to say 4 goes to x. So 4 goes to x. We're not saying they're equal. We're just saying they're connected to each other. Now we can create an equation by cross multiplying. So the x comes up and multiplies by the 3. So 3x now will equal 21 times 4. And 21 times 4 is, what is that? 484. So 3x equals 84. And so x will equal 84 divided by 3. So you might want to get your calculator out. I'm going to do that just to double check. 84 divided by 3 equals 28. And so the answer here will be 28. And then when you write it in here, make sure you include your units. So 28 meters is what you want x to be. Okay? And then we'll do the same thing for the y. So 3 goes to 21. That's consistent. That's what we know. 3 goes over to 21. And 5 goes to y. Okay, and it's the same thing. We'll cross multiply. 3y will equal 5 times 21. 5 times 21, I believe, will be 105. So we have 3y, and y will equal 105 divided by 3. We're going to divide it by 3 on both sides. So I take my calculator again. 105 divided by 3 equals 35. And so the answer here is 35. And again, when I write it in, 35, and I include my units. And that is using or solving with similar triangles. All right, let's move down. And we have some trig ones, and that will wrap up the review. So we're almost there. For each triangle below, find the missing side using the 3 basic trig ratios indicated by SOHCAHTOA. SOHCAHTOA tells us that sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. Okay, so the first thing I strongly recommend students do, although it's not really 100%, and I do give marks for it, so I'm going to say you have to do it, is label the sides with respect to the reference angle. So if this is my right triangle, this here is my hypotenuse, this here is my theta, and this here would be my opposite side. And when I see O and H, I look for which one has O and H in here, and that's sine. And so that tells me what I have to do. So I say sine theta equals O over H, and that's my first step. Do that, get that correct, you get yourself some marks right there. In fact, I think you got 2 marks probably, or 2 marks that I'm looking for just by doing that, okay? You're telling me that you understand which sine ratio you need to use, or which trig ratio you need to use. In this case, it is sine. Now I start substituting in, so I say sine 27 equals O is 5, H is X, and now I have to solve for X, okay? And there was a trick that I showed students, is that if you have X on the bottom, you can simply switch it with what's over here. So it's a sort of a trick game. So X really equals 5 over sine 27. And now I need to run to my calculator, type in 5 divided by sine 27. And I can get my answer. You have to make sure your calculator is in degree mode. And when I do this, I think I came out with 11.0. So 11 is the answer here that I'm looking for. If you want to put 0.0, that's fine. And then don't forget to include your units. And then it's always nice if a student puts a box around it. You know, if you want some bonus marks, you highlight it. You make it nice and easy for me to see. I see you've got the right answer. It's a real easy mark for me. I can see that, yep, if you got the right answer, you've likely used the right trig ratio and you've done everything correctly. And that's a pretty straightforward question. That's finding a side. And then we'll do one here where we're going to find a angle, okay? So in this case, it starts off the exact same way. We want to label our sides. So this here is going to actually be the hypotenuse. This will be the opposite, and this will be the adjacent. Didn't really have to label the hypotenuse, but it never hurts to do that. I often actually start by labeling the hypotenuse because it's always across from the right angle, and it just reduces my risk of making a mistake. Now the hypotenuse is not in play on this one, so it's O and A, and I look at my SOHCAHTOA, and that tells me I should be using tan. So I just simply say tan theta equals opposite over adjacent. I write that down, and I've got myself a nice easy mark for getting the correct trig ratio for this question, okay? Now I substitute in my values. 5 is going to go in for O, 6 is going to go in for A, and I write tan theta equals 5 over 6. And this is a little trickier now because we have to use a second function or the reverse lookup in our calculator. And so what I tell students to really write is theta will equal tan negative 1 5 over 6. And you have to find that tan negative 1 in your calculator. And it's a shift or inverse or some other button. You have to know your calculator to do it. And if you do it, you should come up and make sure your calculator is in degree mode. It's very important that it's in degree mode because that's how we operate it. You should come up with the answer of 39.8. I always recommend for degrees, just round it off to the nearest degree. You know, the difference between 39.8 and 40 is so small in an angle that we wouldn't worry about it. So in this case, 39.8 rounds off to 40. And so I'd be looking for the answer of 40 degrees. And it's important to include the unit degrees up here, okay? That's a way of measuring the angle for anything that we do in math in degrees, okay? There are other ways of measuring, just like there's centimeters and inches and miles and kilometers. There are other ways of measuring, and I'm not going to get into it, but your calculator has that ability to work in those units as well, and that's why it's important to make sure it's in degree mode. It should have a little DEG somewhere, or even just a letter D on the top, very tiny usually, that indicates you are in that mode. If you are not in that mode, you are going to get the wrong answers, guaranteed, okay? There is a bonus question. I'm going to leave it at that. Please go for it and give me your solution. Drawing a diagram might be useful, but in the end, I'm just looking for the correct answer, and we'll see what students can come up with. Okay, that is it, folks. That is the end of the part 2 on the review. Hopefully that went well for you, and you can use this to help you get through your assignment. You can fast forward, replay, watch things, and of course you can always come and ask me more questions if you have any. All right, have a good one, and I hope you enjoyed Luke.